All right, drill number 4. At this point, you probably should have struggled a little bit through this one, or at least tried. That would be my hope. If I was there with you all, I would ask for who might have a possible formula to give me, and I would tell you that if you don't have the correct one, it's perfectly fine as long as you're giving it a shot. So hopefully you guys gave it a chance. And what I'm going to try and do is walk you through the thought process here. Probably going to go a little bit more into detail of different things that you might not really think that you would need, but hopefully you'll find it at least interesting. This is actually a really good example as far as a real life example because um, this is all about how credit cards work and credit card balances and things like that, which I am assuming that most of you probably do not have at this time. If you do, it's probably linked to your parents' account anyway. But in order to actually understand the problem, and that's probably the hardest part about this, is you really do have to have an understanding of what's going on. So let's take a look at this. It says Jack's credit card balance is $12,500. So what that really means is that Jack has gone out and bought a whole bunch of stuff, whatever it is, and he owes the credit card company $12,500. So that's how much his debt is. He's paid, or excuse me, he's gone out and bought a bunch of stuff, and now he owes the credit card company $12,500. At the end of each month, he's charged a 1.5% interest, which means the credit card companies actually take what it is that you owe, and if you don't pay it off within the first month, they start charging you interest for letting you use their credit card company, for basically them paying for your stuff. They're going to start charging you extra money. So, if nothing else, public service announcement. You probably don't want to use credit cards that much. You do need to build up a little bit of credit, so it's not a bad thing to have them, but you want to make sure you can pay it off every single month. Otherwise, you're going to see the results after we go through this drill of what can happen. It's not good. And 1.5% interest is actually quite low. If you actually got a 1.5% interest credit card, you'd be doing really well. Most credit cards are between like 12 and 25%, and that's really high. Anyway, so we'll get to that. So after that 1 month, the credit cards charge you 1.5% interest, so they're adding money to the amount that you owe. And then after that interest is charged, you're going to be like, okay, I got to make a payment, so I'm going to make a $300 payment and apply that to the credit card, and then we're going to be able to see what your balance is. So it says we're supposed to write a recursive formula. Recursive formula. It takes into account the interest charge as well as the payment that it says Isaac makes each month, but Jack's credit card. Okay, so we got some issues there with the person, but whatever. Um, if you remember, a recursive formula means that it depends upon the previous value. So that's what ultimately we're going to try and do. Let's actually do the bottom part before we do the top part, because sometimes it's easier to actually figure out what's happening by plugging numbers in and seeing what's actually going on, and then you can kind of decipher what the pattern is. So we know that we start off with a debt or a balance of $12,500. And then it says we're going to get charged 1.5% interest. Now, hopefully you remember that if we're going to use that value to figure out our interest, or excuse me, to use as a percentage, we're going to have to divide 1.5 by 100, or basically you would move the decimal place 2 places to the left. So that would actually make the usable number for us 0.015. Okay, and that's what we'll use when we actually plug this into a formula or use it as a way to find the value. So if I want to figure out what 1.5% of 12,500 is, I'm going to have to multiply them. So I would take 12,500 and multiply it by 0.015. And we're going to see how much that is. And hopefully you have your calculators and you can plug all this stuff in. And we should get that the interest would be $187.50. So that's the amount of money that they're going to charge us for not paying off that credit card right away. So basically, that money is going to get added onto the $12,500. So our new balance is going to be $12,500 plus $187.50, which works out to be $12,687.50. $12,687.50. Make that a 50, it looks better. Not great, but still good enough. So then that's what we're going to owe, but we're going to make a payment. So we're going to go ahead and subtract $300 because we're going to make a payment to the credit card company. And after we make our payment, our new balance is $12,387.50. So just to give you an idea what we're looking at, because this is only after the first month, we now have a new balance of $12,387.50. That is less than the original amount that we started with, but we made a $300 payment. And if you plug that into your calculator, 12,500 minus our new balance of 12,387.50, we've only paid off about $112, but we made a payment of $300. Okay, that interest is really costing us a lot of money here. And you'll see just how bad it is after we get through the third month. So that's what it is at the end of the first month. Then at the start of the second month here, now our new balance is $12,387.50. And the same thing is going to happen. We haven't paid off the whole thing, so they're going to charge us 15% interest, and so on. And this pattern is going to keep going. There's a way to do this without actually doing the multiple steps. So the first step was we multiplied by the 0.015, and then we added that value to the original amount, and then we subtracted the $300 right here. We can combine these first two steps. What we have to do is think of it like this. $12,500 is a certain percentage of itself. Now think about what I just said. 12,500 is a certain percentage of itself. Well, it should be 100% of itself, otherwise it would be a different number. So $12,500 is 100% of itself. That's this piece. Okay, that actually is represented by 100%. This piece was the 1.5% interest. So if I want to combine both of those two things into one step, I am literally going to do what it says here, and I'm going to add them together. Forgot my percentage symbol. So really what I get is 101.5%. Well, if I want to combine those two steps, let's take a look at what happens. I'm going to erase this over here. And we're going to go ahead and see what happens if I take 12,500 and I'm going to multiply it by 101.5%. Well, don't forget, 101.5% is in percent, so we have to divide it by 100, or again, move the decimal 2 places to the right. So I'm going to multiply it by 1.015. You should hopefully be able to tell it's the same number that we use in the one above. The only difference is there's a 1 out in front. That 1 in front of the decimal place basically refers to the 100%. And that 0.015 refers to the 1.5%. And what you should see, go ahead and plug that in your calculator if you haven't already, and you can pause it here if you want to try it before you see the answer. All right, so if you've paused it and you come back, this typed in should have given you $12,687.50, which is this number up here. And then we still have to subtract the $300. So we're going to then minus $300, and we're going to get 387. Lost a number there, 387 and 50 cents. So basically all we've done there is we've cut out one of the steps, which is nice. So now that's after the first month. We're going to go ahead and finish this off by going 387.50. This will be month 2. We'll call this one up here month 1. They're going to charge us the interest. So we're going to have the original amount. That's the one part. And then the interest is 0.015. And then we have to subtract 300 because we're going to make a $300 payment. So let's see what happens if you plug that in your calculator. And we should get $12,273.3125. If you rounded that after 2 decimal places because we're talking about money, that's perfectly fine. So that's after month number 2. Rinse, wash, and repeat. Wash, rinse, repeat, something like that. We're going to do it all over again. So then it's 12,273.50. Nope, not 50. 0.3125 times 1.015 minus our $300. And let's see what happens when we plug that in the calculator. Times 1.015. Then we'll subtract 300. And I am getting 12,157.4122. So really it's $12,157.41. That's after 3 months. So let's look at the real life application of this before we go back to do our recursive formula. The real life application, we started off with a balance of $12,500. We are now only down to $12,157.41. We have not actually even spent, that's about $343. That's an approximation. I've rounded a little bit. We've only actually brought our balance down $343. And we've made we've made 3 $300 payments or $900 in payments. And we've only knocked off a little over $300. We're not making a lot of progress. The bank or the credit card company is making a lot of money off of us because we're not paying this off. So again, that goes back to my public service announcement. Really try your best not to run up big credit cards because you will have a major debt and it costs you a lot of money in the long run. If nothing else, you'll get a life lesson out of this. All right, now let's take a look at our pattern, see if we can write the recursive. Remember that a recursive depends upon the previous term. Normally, I would make you guys struggle a little bit and figure out what was the actual terminology that we used. A recursive would be an a sub n equals, since it depends upon the previous amount is represented by a sub n minus 1. That terminology right there represents the previous term. And then we're going to take that, and each time we multiplied by 1.015. So we'll multiply that by 1.015. And then we subtracted $300. So that is our recursive formula. It just means that we're always going to take the previous balance, multiply it by 1.015, and then subtract $300. And that gives us our recursive. Okay, there is problems similar to this in the pass the problem / scavenger hunt that you should be working on. So at this point in time, you're able to finish the scavenger hunt. You should be able to get your previous scavenger hunt paper if it was collected the last time, like it should have been. And then once you are completely finished with it, you can turn it in. You'll have the remainder of the period if you need it. However, once you are finished, there is a homework assignment. So once you turn it in, you'll pick up the homework assignment. And it's just more practice on geometric and arithmetic type sequences. And the homework assignment will be due next class. All right. Have a good rest of your day.